let's just see the question number 8. Question number 8 says if the polynomial is given is divided by another polynomial of the type x square minus 2x plus of k, the remainder comes out to be x plus a, then we have to find out the value of k and a. So let's just start the solution of this particular question. As first of all, let us suppose we are taking the polynomial as p of x. So let p of x is x raised to the power 4 minus 6x cube plus 16x square minus 25 of x plus of 10. It says when it is divided by another polynomial, so let us suppose we are taking that polynomial as g of x, which is x square minus 2x plus of k. It says the remainder come out to be is equal to x plus of a. So the remainder is of the type, let us suppose r of x, which is equal to x plus of a type. We have to find the value of k and a. So as per the question, if px is divisible by g of x, it means that we can write it into the formation of x square minus 2x plus of k, and the dividend would be of the type x raised to the power 4 minus 6x cube plus 16x square minus 25x plus of 10. So let's just divide both of these two polynomials. So first of all, we will get x square. So it would be x raised to the power 4 minus 2x cube. It is minus 2x cube plus kx square. It is plus kx square. As k is an unknown quantity, so it is negative, positive, negative. When we will change the sign, both of these terms get cancelled with each other. Minus 6x cube plus 2x cube is minus of 4 of x cube. Further, we will have plus 16x square minus of kx square. We can write it as 16 minus of kx square, as I have taken x square as a common term out of both of these, minus of 25 of x plus of 10. So let's just divide the terms again. We will get minus of 4 of x after dividing minus 4x cube and x square. Let's just multiply minus 4x with all these terms. So we will get minus of 4 of x cube minus 4x minus 2x. It is plus 8x square. So it is plus 8x square. Further, minus 4x plus k minus 4xk. So it is minus 4kx. So again, let us suppose it is positive, it is negative, it is positive. So both of these terms get cancelled with each other. So at the end, we are getting 16 minus k minus 8. 16 minus k minus 8 is 8 minus k, because 16 minus 8 is k. 8, sorry. So 16 minus 8 is 8. So at the end, we are getting 8 minus k x square being a positive term. Again, we have minus 25x minus is nothing but again plus. So it is plus 4k. So let us suppose I am taking x as common from this term. So we will get this term as nothing but, let us suppose I am writing positive in between, minus 25 plus of 4k of x plus of 10. Because we cannot add or subtract these two terms, as both of them are not like, because we do not know the value of k over here. So we can write it into the formation of this. Now let's just again divide these two first terms, because we do know that the degree is same. It means that we can repeat the division algorithm again. So plus of 8 minus of k we will get when we will divide both of these first two terms. So at the end, we can write it as 8 minus k x square. 8 minus k when get multiplied with minus of 2x, we will definitely get the answer as nothing but, let us suppose I'm writing it as plus of, we will get minus of 2 into 8 as a minus of 16, minus of 2 minus of k, it will be plus of 2k, plus of 2k of x. You can multiply it over here as well. So as we can see, we are multiplying minus of 2x with 8 minus of k. We will get the answer as minus of 16x plus of 2kx. So I'm taking x common out of it, so it would be minus of 16 plus of 2k of x. It means we can write it as of this form. So minus 16 plus 2kx. Further, we can write it as 8 minus of k plus of k, which is nothing but 8k 8k minus of k square, 8k minus of k square. Now let's just subtract all these terms together. It would be negative, it would be negative, it would be negative again. We can write it into the form of negative term. So let's just cancel out these terms get cancelled with each other. So at the end we have to subtract all these terms. So we are subtracting, let us suppose we are subtracting these two terms. So we can write it into the formation of minus 25 plus of 4k minus would be plus of 16 plus minus would be minus of 2k of x, I'm taking x common, plus of 10 minus of 8k plus of k square, minus plus minus, so the sign of the 8k would be negative, minus is plus, so plus k square. So at the end we are getting the terms in this particular formation, and furthermore we can see that the degree of this particular remainder is definitely less than the degree of the divisor. It means this is the end and this is the remainder. So let us suppose I'm solving it further. I'm solving it further as we have minus of 25 plus of 16, so this is minus of 9. Further we have plus of 2k of x plus of, further we have 10 minus of 8k plus of k square. So this is nothing but the remainder. So this is nothing but the remainder that we are getting at the end. At the end we are getting this particular remainder. So from this particular things that are given to us in this particular question, we do know about the remainder. The remainder is given to us, which is nothing but is equal to x plus of a. But at the end, after dividing these two polynomials, we are getting the remainder as minus 9 plus 2k x plus 10 minus 8k plus x square. So what we can say at the end, we can say the remainder is coming out to be equal to minus of 9 plus of 2k of x plus of 10 minus 8k plus of k square. But we also do know about the remainder. Which is already given to us in the question, that is x plus a. So it implies that the equation number 1 is definitely is equal to the equation number 2, because we definitely do not have two different remainders. Both of these should be equal to each other. So we can represent it as minus of 9 plus of 2k of x plus of 10 minus 8k plus of k square, which is equal to x plus of a. So by comparison, let's just take a comparison in between both of these. By comparison, let's just compare the coefficient of x and the constants in both of these terms. So by comparison, the coefficient of x over here is minus 9 plus of 2 of k, and on that side the coefficient of x is nothing but 1. So the very first equation that we get is nothing but minus 9 plus 2k is equal to 1, and the second equation would be like the constant in this term is 10 minus 8k plus a square, but on the other side the constant is a. So let us suppose I'm calling this equation as equation number 3rd and this is equation number 4. Let's just solve equation number 3rd first for the value of k. So we can write it as 2k is equal to 1 plus of 9, which is equal to 10. At the end 2k is equal to 10 means k is equal to 5. So we are getting k as nothing but is equal to 5. So let's just substitute k is equal to 5 in the equation number 4 in order to get the answer of a. So let us suppose I'm substituting k as 5 over here. So it would be 10 minus of 8 into 5 plus of 5 whole square is equal to a. So it is 10 minus of 40 plus of 25, which is equal to a. So it will be 35 minus of 40, which is equal to a. So at the end we are getting a as nothing but is equal to minus of 5. So this is nothing but our answer. So at the end what we are getting the value of k as nothing. Let us suppose I'm writing it over here. The answer is k is nothing but is equal to 5 and a is nothing but is equal to minus of 5. This is nothing but the solution set or the answer of this particular question. I hope all the steps are all clear to you.